Doing nothing or doing a lot of activity. Have you ever wondered how can you stay in a stable state? If you suddenly feel hot and sometime later you don't feel hot anymore, like nothing happened, that's because of homeostasis. It's your body's way of balancing and keeping you comfortable. Imagine you're outside on a scorching hot midday. You feel the intense heat all around you. Then you enter a cold place, like a mall. At first, you immediately feel the chill. It's such a contrast to the hot day outside. But after some time, the temperature starts to feel normal again. Not too hot and not too cold. This is homeostasis at work. Homeostasis helps your body adjust to changes, making sure everything stays balanced and just right. So whether you're lounging around or running around, your body is always working behind the scenes to keep you comfortable and healthy. Isn't it amazing how your body takes care of you without you even noticing? So, what is homeostasis? According to Britannica, homeostasis is a self-regulating process by which biological systems tend to maintain stability while adjusting to conditions that are optimal for survival. This means it is a process that maintains our stability through dynamic equilibrium, where continuous changes occur, yet relatively uniform conditions prevail. Homeostasis is crucial for our survival and proper functioning. Here are a few examples. First, temperature regulation. When the weather is hot, you sweat to cool down, and when it's cold, you shiver to warm up. This helps keep your body at a stable temperature. Next, blood sugar levels. Your body needs to balance glucose level in the bloodstream. Insulin helps lower blood sugar when it's too high, while glucagon helps raise it when it's too low. Homeostasis ensures that your body remains in a stable state no matter the external conditions. To maintain homeostasis in our body, there are mechanisms called feedback loops. These biological mechanisms help regulate internal conditions in response to changes, keeping everything balanced and stable. Feedback loops include several components: the stimulus, variables, receptors, control centers, and effectors, which work together to either stabilize or amplify a process. Variables. These are parameters that are monitored, controlled, or affected by the feedback system. Examples include body temperature, blood sugar levels, and water balance. Receptors. These are sensory cell organs that detect change in variables. For instance, temperature receptors in your skin detect changes in external temperature. Control centers. These acts as integrators, comparing the variable in relation to a set point, the desired level, and signaling the effectors to generate a response. For example, the hypothalamus in your brain acts as a control center for regulating body temperature. Effectors. These execute the necessary changes to adjust the variable. For example, sweat glands act as effectors to cool down the body when it's too hot, and muscles shiver to warm up the body when it's too cold. Feedback loops have two main types: negative feedback loops and positive feedback loops. Let's dive into each one to understand how they work. Negative feedback loops. Negative feedback is a control mechanism in which a change in a system triggers a response that counteracts or reduces the initial change, helping maintain stability or homeostasis. This is the body's way of keeping internal conditions within a normal range. Examples of negative feedback. Blood sugar regulation. When your blood sugar is high, your pancreas releases insulin, which lowers your blood sugar, resulting in a balanced blood sugar levels. And when your blood sugar is low, your pancreas releases glucagon, which raises your blood sugar, also resulting in balanced blood sugar levels. Next example is calcium level regulation. When you have a low blood calcium, your parathyroid glands releases parathyroid hormone, which raises your calcium levels. balancing your calcium regulation. And when you have a high blood calcium, your thyroid glands releases calcitonin, which lowers the calcium levels in your body, again, balancing your calcium regulation. Negative feedback counteracts the initial change that happens in our body, maintaining stability and homeostasis. The next feedback loop is positive feedback loops. Positive feedback is a control mechanism in which a change in a system triggers a response that amplifies or enhances the initial change. Unlike negative feedback, which stabilizes conditions, positive feedback pushes a process further in one direction until a specific outcome is achieved. Examples of positive feedback. First is fever or immune response. When an infection is detected, the body raises its temperature to fight off bacteria. The higher temperature increases immune activity, and this continues until the infection is eliminated. Afterward, the body restores the balance in temperature. Next example is childbirth or labor contractions. When a baby pushes against the cervix, oxytocin is released, causing stronger contraction. More oxytocin leads to even stronger contractions, and this process continues until birth. After birth, hormone levels return to normal and the body stabilizes. Positive feedback enhances the change that happened in our body until completion, playing an essential role in overall homeostasis by completing critical processes that restore balance. Negative feedback and positive feedback assist in the process of maintaining stability in our bodies. They ensure that our body works in an efficient manner and remains stable in reaction to internal and external changes. The relation between negative and positive feedback assists the body in adapting and responding to situations appropriately, thus maintaining homeostasis in our body.